Again. So here's our relationships. 1 mole of N2 equals 1 mole of O2. The chemical equation tells us that. Does everybody agree? Yeah. How many conversion factors do I get from that? 2. 1 mole of N2 over 1 mole of O2. And it also gets me 1 mole of O2 over 1 mole of N2. So every equality gets me 2 conversions. How many equalities do I have from that chemical equation? 3, because I can relate A to B, A to C, and B to C. So there's 3 different relationships that can come out of that chemical equation. Because each of those relationships generates 2 conversion factors, a single chemical equation gives me 6 conversion factors. Okay? This is one of the things that becomes exceptionally powerful of a chemical equation, and is also one of the reasons why students tend to kind of lose focus on how to do a conversion. Okay? When you run a conversion, you only need one of those conversion factors ultimately at any given instant. Okay? You have to recognize that that chemical equation can give you a lot. You have to choose the correct one. For just this one equation, there are 6 possible choices. How do you know which choice you should use? To write an essay, we could go classical oratory style, we could write Rogerian, we could write IMRD, and that's just keeping it simple, 3 different forms. Which of those 3 different forms should you be trying to do? Depends on what you want to do. It depends on the context of the assignment, the broader thing you're trying to do. So in chemistry, what is our broader context that would allow us to decide which of those conversion factors we should use?
The equation? Does the equation set rhetorical purpose? Does it tell you what your job is, what you're trying to do?
The equation just says, here I am, ta-da.
Equation is just facts.
What's going to allow you to decide which of those pieces you should use? What the problem asks for. It's the question. You need to be using the question to guide which factor to use. Okay? That's why we bring in units, because the units allow us to decide which of those to use. Okay? And it is all too common when we go through and try and set up a conversion, we start throwing numbers in. Okay? Well, there's a bunch of different numbers here, and those numbers could result in a whole bunch of different answers. We have to choose the proper sequencing of numbers. That proper sequencing comes from the conversion factors. Okay? So, same equation. Which of those conversion factors should we be using? Well, how do we solve it? So, and I see you all looking at it, and that's great, and you're trying to process through and think about what it is in your head, and that's phenomenal. Okay? That's really impressive, because you are trying to make that big leap. I'm not asking you to make that leap. And in fact, I'm telling you not to make that leap. Okay? What I'm telling you to do is go through and solve the question by writing it down. Your first step should be writing this information down so that you don't have to make that big mental leap. All you have to do is look at what's given and say, well, what do I need to make that conversion? By writing it down. If you don't write it down, you are making a massive mental leap. The problem with making massive leaps, you're probably going to mess up, right? And it's going to hurt. And in the case of a class, it's going to hurt because you're going to fail the class. So I don't want you to make that massive leap. Right? And at this stage, we're in a fundamental class. You should not be making that massive leap. You should be committing to making those smaller steps, because those smaller steps are going to get you there better. Okay? Kind of like what we're doing in the writing assignment. Okay? With that writing project, what do we expect you to turn in on Saturday? 1,600 words? No. What do we expect? A draft, a map. Something that progresses you towards that goal so that the end goal isn't a big, massive leap. Because what happens if we just said 1,600 words on Saturday? How good is that project going to be? Okay? That's going to be horrible. Okay? Both for you emotionally trying to write 1,600 words and for us emotionally trying to read your 1,600 words.
For the record, writing that much in one day, even for me, is really annoying and stressful, so don't do it.
Okay? So we want to commit to writing things out. And for those of you thinking, God, okay, you're making me write it out, fine, it won't happen again, future classes I won't have to write it out. I am literally telling this exact same thing to students that have already gone through 2 years of chemistry. And exactly what they're trying to do is make a leap. Stop leaping. Okay? Education is about making small progressive steps, not big bounds in thought. Okay? Take those smaller steps. So what is our smaller step?
Writing down
Writing what down?
the question.
And I would argue the question is okay to write down, but theoretically you shouldn't be writing down the question now because
It's already written.
it's already written where? In your notes, because you've printed out the PowerPoint notes and you have those notes already written down, so you don't have to waste the time writing the question.
That's an option.
A couple people are laughing, and you're probably laughing because I didn't print those out. Okay? You go look around the classroom, nobody printed those out. I've told you to print them out multiple times for this very reason, so you aren't wasting time writing that information down. Okay? You should be immediately jumping to, what do you want? Because that's the step one in our solve. What do we want? Okay?
But if
The
you didn't
moles
print it
of oxygen. If you didn't print it out, then sure, fine, write out the question. I still get a little irritated at that, but that's okay. Moles of oxygen. Awesome. What's our next step?
Write down what else,
Okay.
right? 2.25 moles of nitrogen.
And I'm going to argue 2.25 moles of nitrogen is wrong.
Oh, it will react. How many moles of oxygen react?
So, okay, why am I going to say 2.25 moles of nitrogen is wrong?
Because we shouldn't.
Because we shouldn't be assigning numbers.
Oh.
We shouldn't be assigning numbers yet. We should be writing the unit. Starting with moles of nitrogen. You don't have to apologize.
Leaping.
Okay? It's one of those, and it's such a small leap that everybody's like, it's not that big a deal. Okay? The habit of writing down that unit is what's going to allow you to set up and do your processes correct later on. If you get in the habit of writing the number, what ends up happening is you stop writing the unit and you start only writing the numbers. Well, now you don't know why you're placing the numbers where they're supposed to go. So what I'm trying to do is build a habit of writing the units so that you can later decide where the numbers go. Okay? So, now what do we do?
I would start on the right side and do, right, put moles of oxygen on top,
Okay?
right?
So I know where you're going. You're saying, are those things equal to each other? Do they have the same units? No. So your argument is that I know I need to do something here. In that something, you know that you want moles of oxygen on top. Why?
Because that's what we're ending with.
That's what we end with. Shows up on top. Fantastic. Right? What else do we know? Do we know the moles of oxygen?
No.
No. So what does that mean? We're going to have to do a conversion, okay, where the moles of nitrogen must disappear. Okay? That was kind of our old logic and process behind it. Okay? I would argue we can take a slightly new tack now behind this. Moles of nitrogen, moles of oxygen, are those the same thing? No. What changed? The substance. Okay? So now what we're doing is not just saying, well, what do I have? Just start mashing things in there to align those units, because that's what we could do with conversions, with just standard unit conversions. Okay? Now things get a little bit trickier because the substance will also change. So what we need to do is look at our unit and decide measurement and substance. What is changing? In this case, the substance is changing. So now that I know the substance is changing, I have to think about how do I change the substance. Right? And here's where I would write N2, I know as a unit or a substance needs to be canceled, O2 needs to disappear. Where do I find a conversion factor that relates how two different substances? From the chemical equation. What are the units in a chemical equation? The phase is in a unit. Does that equation tell us the number of grams? It's a counting unit. So this could be molecules of O2 and molecules of N2. Perfectly fine. Or as Ali suggested in the past, we could call them compounds of O2, compounds of N2. Right? If we did that, that would work for us. I'm just going to write CPDS for compounds. Okay? But before we start writing that, let's consider that. Do we have the ability to measure single molecules or single compounds? No. That mass is now so insanely tiny, we can't measure it well. Turns out, a student came up and talked to me after class Tuesday and said there is a balance now that measures it. It's roughly the size of a table. It costs $19 million, and it can measure 10 to the minus 24. Wow. For $19 million, we can measure a molecule. That kind of sucks.
Wise investment.
Okay? Do we have a better system? Do we have to measure it as individual compounds? No, what are we going to measure it as? We will scale it up so that we're now looking at a counting unit of moles. So when we look at our chemical equation, we have to acknowledge that we can do this as molecules or compounds, or we can measure it as moles. Moles are more valuable to us because we can measure a mass for a number of moles. That's now a reasonable size that we can deal with. So when we think about the measurement unit for converting substances, moles is the optimal one. Okay? In a lecture, you could be forced to do molecules. Right? But moles is going to be our primary one. What numbers should now be associated with those moles? So 6.022 times 10 to the 23rd is fantastic if I was not converting substances. 6.022 is Avogadro's number. 6.022 times 10 to the 23rd things equals 1 mole. There's our mole of things. Did I convert the substance here? No, this is things to things. Is that what I want? No. So it does bring in moles. So that's a good step. Right? That unit does show up, but I'm converting substances. Avogadro's number does not convert substances. So that doesn't work. Where do I convert substances? From the chemical equation. Do we have a chemical equation that relates nitrogen to oxygen? Yes. Right? Is that chemical equation balanced? What are the numbers associated with oxygen and nitrogen?
2.
Well, nitrogen.
That would be the coefficient in front.
Oh, okay. So
1 and
1.
1. What numbers show up in my conversion factor? 1 and 1. What happens? Moles of N2 cancel. Would I have moles of O2? Yep. So my answer is 2.25. This would be, well, that was the same number. Why didn't you just write 2.25? Do you have any idea why you wrote 2.25? Right? Now we do. That's the point of that work, is to help you kind of frame why the numbers make sense. Not just, well, it's the same number, so I'm always going to write the same number. That doesn't work. Make sense?
I need a drink. Coffee's right there. Oh, that's not much better.
So, and a lot of it is, again, just that process. Okay? In that process, we have to be thinking about where each of those things are, okay? And always go back. What do we have? Okay, what are we trying to find? What do we have? The next question we have, what do I need? Moles of O2. Because that's what I had and what I want in the answer. What do I have? I have moles of N2. Is that a conversion factor? Yeah?
Yeah.
Put the numbers in. What if that didn't convert? What do I need? What do I have? What do I need? What do I have? Every conversion is the exact same questions. What do I need? What do I have? Is that a conversion factor? Yes? Put your numbers in. Not a conversion factor, you have to delete one and make it a valid conversion factor. Which conversion factor do you choose? I want to go hours to days. Should I convert into seconds?
No.
Why not?
Because you're,
That was really fast. How'd you guys do that? You're used to dealing with those unit systems. You need to get used to dealing with these unit systems. How do you get used to it? By doing it over and over again. For those of you asking about the time one, how long did it get you to figure out that time one? Seconds now, but when did you build that knowledge? How long did it take you to build that knowledge?
Long time.
A long time. Probably more than 16 weeks. How much time am I giving you to figure it out?
Lost
2 weeks. Okay, why 2 weeks?
That's when our exam is.
That's when our next exam is. Okay? So you need to be working twice as hard, at least, to get that practice in so that you can be ready for the exam. Okay? When we did the time one, you probably did that across a huge span of time, but you weren't constantly looking at it. Okay? It was random things that just kind of popped up. Well, now, don't allow for that random thing because that's going to take you 20 years to figure it out. I don't want to do that. So now what you have to do is force that practice on yourself to make sure you can get that alignment faster. Make sense? Okay. So, the equation concept and its strength. How many moles of CO2 are necessary to make 1 mole of sodium hydrogen carbonate? What's our process? What do we want?
mole sodium carbonate.
Do we want moles of sodium hydrogen carbonate? So let's go through and let's just do that. Let's say, hey, you know, that's what we're asked to find. Moles of sodium hydrogen carbonate. What was I given? I was given 1 mole of sodium hydrogen carbonate. Are those two things the same units?
Yes.
Yes, which means?
The,
So you're answering the next question. Are those units the same thing? Yes, which means? It's the answer. That was awfully easy. I didn't have to do any conversions. Why was it awfully easy? Because you didn't answer the question. What's the question? Moles of CO2. Okay? So it is okay if I think, oh, the answer is moles of sodium hydrogen carbonate, write down what I'm given. Oh, I didn't do anything? And I can understand why you would do that. Okay? And I'm going to blame Greg for this. That's the English language. Okay? It's the English language that's messing with your head. So that's why we write it down and put it into the math language, because now we can see that and be like, yeah, that sounds a little too easy.
Because some things are easier to understand when coded a different way.
Way to take a cop out and say it's not your fault.
Writing systems. Hashtag writing systems.
Okay? That's why we shift into that other system to allow us to see that cleaner. Make sense? Right? So now when we look at it, moles of sodium hydrogen carbonate, moles of CO2, are those the same thing?
no.
No. So what's the question we ask?
How do you convert?
I would argue no. That's too advanced.
Are you asking what to do next? Wouldn't you put,
And
you see the sodium hydrogen carbonate on top?
so, and
Or
this is
no?
where we got to be a little bit careful. I'm not necessarily asking what to do next. What I'm asking is, what is the question that the answer would be what we do next? Do we already know what we're trying to solve for, though?
As far as the conversion, what are we trying to solve for?
Okay. What do I want?
Is it the CO2 over the?
I want moles of CO2. What do I have? Remember, numbers are meaningless until we associate a unit with them. Okay. We have moles of sodium hydrogen carbonate. I now have a conversion factor. What are the numbers associated with that conversion factor? We're now converting substances. Where do I find a conversion factor to convert substances? From a balanced chemical equation. Do I have a balanced chemical equation? Yes, right there up at the top. Balanced chemical equation. What are the numbers from that balanced chemical equation? 1 CO2, and then I'm hearing 1 sodium hydrogen carbonate. Okay, this could be our hashtag writing systems. I probably should have put a space there. Okay, a lot of people seem to lose that 2 without the space. Okay, so that 2 is in there. I don't know if that's a writing system thing or not.
Well, it's hard to say, like, because like math does it, but I think because that's such a long string of text, it's small. Like, I don't know if a full space, but yeah. You decide.
So now what happens? So we would evaluate. Moles of sodium hydrogen carbonate cancel. Do I have moles of CO2? No? What's the unit left over? Moles of CO2. Do I have moles of CO2? Yeah, so what do? Math. 1 times 1 is 1. Divided by 2? Right? 0.5. What's my answer? 0.5 moles of CO2. Is that what I was looking for? Yep. Done. Okay, you could keep it as 1/2. That seems way easy. Yes! Exactly. A single conversion. Is that what you actually said? Or did I just...
Yes.
Okay, good. Yes! A single conversion is way easy as long as you have the units to locate where those numbers are. If you don't have the units to locate where those numbers are, it now becomes impossible and you're just throwing numbers at it and hoping it works. Right? In this question, I can tell you as answer choices, we would have this. 1, 0.5, 2, 3, and I am out of options.
Pizza.
Okay? Why has that now become problematic? Any of those numbers can come from any of the numbers listed up in the question. You can't just say, well, I'm going to shovel numbers at it until it works. It's going to work. I will give you an answer choice that works. You have to know why you're doing those calculations. Right? A single conversion should be easy because the unit systems align it. By that same token, shouldn't 4 conversions be easy? Like, well, no, that's 4 times as hard. So it's 4 times as easy. Okay? Each of those conversions is individually easy. What am I asking you to do to go through and do a solve? Multiple individual conversions. If each individual conversion is easy, the whole question is easy. You just have to string those conversions together. Well, why do you pick the conversions you pick? What do you want? What do you have? Does that exist? Yes? Numbers. Does it not exist? That's harder. Right? And we'll look at that in a not that one. We'll look at it with this one. Okay? So the last one on there. You guys want to try that one on your own, or do you want to walk through it together? Greg just said you got to do it on your own. So everybody can stare back at Greg and yell at him.
It has to be easier.
Let's talk through it. What are we solving for?
Grams and
Grams. NaHCO.
Okay.
That's what I put.
So that's what we want. What are we given?
2 moles of
What is it? 2 moles? Okay. Are those the same thing?
I didn't put 1.
Okay. The 1 ultimately doesn't matter. So don't stress. If you ignore the 1, ignore the 1.
No, I
Are
put
those
2.
the same thing? Did you put 2 underneath? You said 2 moles of CO2 over 2.
Over 2.
Where did you get that 2?
Right there. The 2 NaHCO2 3. That's what I put up on there.
Okay. You took that and put it
And
there.
put it there.
Okay. So by doing so, where did you get this 2 from?
From
Okay. So let's write that out.
at the right in the problem, 2 moles of CO2. I put that, and then I put.
Okay. So that's what you got, right?
That's what I.
Okay. So now let's break that down because that's a good question. What you've done is taken all the information that's there and you threw it all into one thing. Should you throw all of your information into a single spot? No. The only thing that shows up in a single spot is a single unit of information. What is that single unit of information? 2 moles of CO2 came from where? From the question. Did the 2 moles of sodium hydrogen carbonate come from that same spot in the question?
No.
No. At best, what you have done is you've combined conversions because that 2 moles of sodium hydrogen carbonate came from the equation, not from the question. Okay? So what you're saying is, well, I'm going to take 2 pieces of information and put them together. That's phenomenal if you're right. You're not. And because you're not, your whole system crumbles. Okay? This is why, even back in chapter 2, I said, in an individual block, you put in 1 piece of information. Okay? That doesn't mean only 1 number and 1 unit. That means 1 piece of information. So you have to acknowledge where that information came from. 2 moles of CO2 came from the question. 2 moles of sodium hydrogen carbonate did not come from the question. That came from the equation. You've combined 2 different sources of information. That's why your system is falling apart. At this point, what you're doing is saying, well, I want moles of sodium hydrogen carbonate, so I'm just going to put it in there. No! Why are you putting those things in? Okay, that why is huge. Okay? Get rid of that arrow, because I don't want that arrow. Okay? As a single piece of information, that's all I have, 2 moles of CO2. If you don't want to include the 1, you don't have to include the 1. The reason I include the 1 is to show that this 2 moles of CO2 is in the numerator. Why did I place it in the numerator and not the denominator?
It's not a conversion.
Nothing about the question really allows me to see that. Okay? I'm placing it in the numerator because that's the only spot I really have to use it from. Okay? And it may turn out to be the wrong decision. I will know it's the wrong decision because when I go through to solve, will my units match each other? No. Okay? So if I go through to solve and the units don't match, what can I go back and do? Rearrange. Instead of placing the moles of CO2 in the numerator, I'll now place them in the denominator. So what we're doing is taking an educated stab at this and saying it is easiest for me to place this in the numerator. That's where I'm going to place it. And I'm going to cross my fingers and hope for the best. Okay? If it doesn't work, what do? I redo it. And I redo it back where I made that initial assumption. That's my initial assumption. So I would go back and place it in the denominator and try again. Okay? So, moles of CO2, the same thing as grams of sodium hydrogen carbonate. No. Okay? Here's where we can encounter 2 potential tacks behind this. 1, what do I want? Grams of sodium hydrogen carbonate. What do I have?
2 moles of CO2. Oh,
just the unit. Okay? Because the number comes from what is this piece of information. This would now be a single piece of information, ideally. That is a conversion factor. That single piece of information is ultimately coming from this relationship. Grams of sodium hydrogen carbonate equal moles of CO2. Okay? That's my conversion factor that would allow me to relate those. Okay? So now the question that we get asked, or that you should be asking yourself, is does that conversion factor exist? Okay? And we're hearing some no's. Where could we possibly find information? What do you got, Joey?
Nothing.
Okay. Have we seen where to find grams and moles?
Avogadro's number. To an extent.
Avogadro's number is not at all true. Avogadro's number is a counting unit that only relates moles to things. Grams is not a thing. Grams is a measurement. Moles do not deal with measurements. Okay? Where do I find the relationship between grams and moles? The periodic table. That's the atomic mass. Okay? And ultimately the molar mass. Okay? So if I tell you a molar mass of 16, what can you tell me?
Oxygen.
Oxygen. How does that relate to the molar mass for ruthenium?
Doesn't.
It doesn't. The periodic table doesn't show that equality at all. So when I look at that measurement, grams to moles, cool, the periodic table tells me grams to moles for what? A single substance. Is the substance the same in my conversion? No. Does that conversion factor exist? No. This is where you run into that question. Well, crap, if that doesn't exist, what do I do now? It's your choice. Your choice is, do I want to deal with the grams of sodium hydrogen carbonate or do I want to deal with the moles of CO2? Okay? That choice could be a difficult one, and it is a branch point because one of those paths can lead to a complete and utter dead end. The other path would be successful. So is there another tack that we could take to ensure that we approach the correct path? Okay? And we've talked about this one. Let's look at the units that we have, or that we want, and the units that we have. What changed?
Moles to grams.
Moles to grams. What part of the unit did we convert? A unit has two pieces. What part of the unit did we convert? We converted the measurement when we talked about moles to grams. Is that the only thing that changed? No. What else changed? We went from CO2 to sodium hydrogen carbonate. We have two conversions, which means when we go through to write in our lines, how many conversions do we need to do? We need to do at least two. One to convert the measurement, one to convert the substance, because those are two separate systems. They're not tied to each other. Okay? So which one should we evaluate? Okay? So moles won't count because I said measurement or substance, and we've got a suggestion here for a substance. Okay? I'm going to say no. And we'll see why I'm going to say no here in a second. Let's convert the measurement. So instead of going into moles of CO2, I'm going to need to go into grams of CO2, because I can't convert the substance the same time that I convert the measurement. For those of you writing this down, this is where you need to pause and think about what's happening. Okay? Why would Mike be taking me down this path?
Because you eventually need to get to grams for the.
So this is, again, if you don't know that why, you might hold off on writing. Where do we find the conversion between grams and moles? Periodic table. So I would look it up. Carbon is 12. Oxygen is, and a second oxygen would be another 16. So I'd get a total of 32 and 12, 44. That would be 44 grams is 1 mole. If we look at the process, what's now happened? I got rid of moles of CO2. Awesome. Okay? And I would get grams of CO2. Is grams of CO2 what I want? Okay? So what do I want? I want grams of sodium hydrogen carbonate. What do I have? Grams of CO2. Yeah? I'm now converting substances. I'm not converting the measurement unit. Awesome. Where do I find the substance conversion? From the chemical equation. A substance conversion only comes from a chemical equation. If I give you chocolate chips, how do I know how to make cookies? I look at a recipe. What is a chemical equation? A recipe. Could those same chocolate chips be used to make banana bread? Yeah, that requires a different recipe. So I have to make sure that I'm following the recipe that is supplied. I've got the recipe supplied. Okay? That recipe tells me the number of each of those pieces that goes in, right? Is the number of pieces the same thing as grams? No. So what is the measurement unit coming from a chemical equation? Stuff is a little too vague, but it's the right idea. Moles. Am I in moles? Does that conversion factor exist? No. Which means this is a dead end, didn't solve right. Okay? That is hard because you're having a hard time dealing with what the process is. To recognize that you're at a dead end is a huge thing. Because if you don't know what the steps are, recognizing that you've hit a wall is going to be hard. Okay? So, where did our misstep happen? Changing the CO2 to grams. So let's go back to our starting point. Moles of CO2 to grams of sodium hydrogen carbonate. What things changed? The substance changed and the measurement changed. I went through and I dealt with, in that first question, what did I do? Or first attempt? I dealt with the measurement. Okay, and I didn't consider the substance. Maybe instead of considering the measurement, I should look at the substance. What happens if I now change my focus to looking at how I convert CO2 into sodium hydrogen carbonate? Where is the conversion factor to convert that substance found? In the chemical equation. What units are associated with that chemical equation? 1 is a number, 2 is a number. Moles. What are the numbers associated with those moles? 2 is in front of the sodium hydrogen carbonate. 1 is in front of the CO2. This sets me up with the exact same system I had in the previous case, the top case that failed. I canceled moles of CO2. Oh, so it must fail now, so I'm going to give up. Okay? No. Pause and propagate it out till you're like, that doesn't exist. Right? What do I want? Grams of what?
Sodium hydrogen carbonate.
What do I have? I don't have 2 moles. What do I have? CO2 is better. Moles of CO2. Do not bring numbers in. The numbers come from that relationship. You have to establish what that unit relationship is first. Then you can deal with the number. The 2 that you're bringing in came from here. And arguably, did you have 2 moles of sodium hydrogen carbonate? No, you had 2 times 2. You had 4 moles of sodium hydrogen carbonate. So that 2 comes from that conversion factor. What we need to address when we're asking what do we have, I don't care about the numbers. I care about the unit. Once I have the unit, I can deal with what the numbers are. I have moles of sodium hydrogen carbonate. Okay? That's the only unit that's left. That's the only thing that's right there. Okay? Now that I have units, I can ask myself, does that conversion factor exist? Where does it exist? In the periodic table. The periodic table tells me the relationship between mass and moles. That would be the molar mass of each of those elements. So I would take sodium, which is
30. Or 22, I'm sorry, so 23. I thought I said 29.
It's okay. Sodium, which I'm just going to say is 23. Hydrogen, which is 1. Carbon is 12. Oxygen is 16 times 3. So that 48.
Do you want us to round up or no?
We'll address that in a second. You told me 84. 84 grams per 1 mole. Okay, let's take a minute and look at where we found these things. This came from the periodic table. This came from our equation, our balanced chemical equation. This was given. Look at the wrong path. What did we do? Given, periodic table. Okay. They're effectively the same things. But doing that conversion at the proper time allows you to recognize when and where to do them and to do the proper one. Notice the thing that's happening at the periodic table, the number associated with it is different. Why is the number different?
Because the chemical.
Because the substance is different. Okay? Finding those pieces and acknowledging why you're doing them becomes the important thing. I can find those numbers anywhere. Both 44 and 84 are numbers that come out of this question. Which one of them was useful? Okay? The only way we know it's useful is because we set up the unit system that allows us to show that we get that answer. Okay? That first one, we could go kind of to the Toolman model if we wanted. Everybody should buy a hybrid car. Is there a flaw in that argument? My 2-year-old should certainly not be driving. Okay? What was the flaw here? The units didn't align to give us a relationship that was valid. Okay? When we make the statement, everybody should buy a car, okay, our everybody is people of driving age. Okay? We have to balance out why we're making those choices as we move through this. Okay? And if we just start saying, well, I can just do it, that becomes a little bit questionable. You have to think about each of those individual steps. Okay? You have to know where those things are found. Okay? At this stage in the game, chemistry is bringing in 2 big conversion factors that you have to know where they are found. The relationship between mass and moles for a single substance, and the relationship between substances and substances from a chemical equation. Chemistry tells you you need those. Everything else is just a unit conversion that you should be awesome at because of Chapter 2. Yes, Krista.
Okay, so when do you use whatever's number? What's the first?
When should you use Avogadro's number? And so that becomes the next thing is, well, but we talked about Avogadro's number. Shouldn't I use it? Okay, well, one of the arguments that I presented when we talked about it is you rarely use it. Okay? It doesn't make sense to use it. We literally picked the number of Avogadro's number, 6.022 times 10 to the 23rd, so that what happens?
We can scale up so that way we.
Which means what happens with that number? I don't use it. The point of Avogadro's number is a number so perfect as a conversion factor that I don't have to use it.
So are you going to put it in the exam?
Okay? So are you responsible for converting it? Do you have to know what it means? Yes. When would that show up? What is Avogadro's number? Number times number. Ah. There becomes the problem. What did you just memorize? The number. What did you not memorize? The effing unit that it belongs with. The whole conversation we've had is stop memorizing numbers. Because what are you doing with the number? Completely screwing it up. The number is going to screw you over every time. Talk to anybody that does mathematics. How many people enjoy math? Nobody. Why? Because math screws you over. Okay? The unit system is what's going to drive your mathematics. That's what drives your calculations. So you have to know the unit. If you learn nothing else in this class, you have to know the meaning behind what you're doing. That meaning, in the case of all mathematics, is the unit. So when we say number, what is the unit? Okay?
That's why it's confusing. It's like,
So let's pause and take a look at that, because you're like, it's mole. Number is mole.
no. Yeah.
12 moles is equal to, sorry. Ah! 12 dozen is equal to 1.
1 dozen equals 12 things.
What did you guys just tell me? 6.022 moles is equal to 1. 1 what would be a good statement to throw in there. Just like this, 12 dozen equals 1. You might be able to process that because you're already associating a substance with it. What's that substance you're tying into that? Eggs.
I was going to say donuts, but yeah.
I was thinking donuts too. 1 egg is 12 dozen eggs?
No.
No, that doesn't make sense. Because what is dozen? 12. What is mole?
A substance. Unit. Something.
A mole is a number. What is a dozen? A number. A number of what? Stuff. Things. What are our things in chemistry? How dare you, Greg?
Sorry.
Atoms. So 6.022 times 10 to the 23rd atoms is 1 mole of atoms. You have to tie the unit to it. Okay? And the problem that we have is we get this big number and we start going, oh, I need to memorize the number. Yes, you need to memorize the number, but the number is utterly useless if you don't tie it to the unit. If I say 12 dozen equals 1, you all think I'm an idiot. Guess what's happening when you tell me 6.022 times 10 to the 23rd moles is one thing?
I think we're idiots.
I didn't say it. Okay?
Thank you.
I thought it was going to say you led us to think.
Okay. I did not lead you to think it, because what did I tell you to do? Look at the unit and focus on the unit. Tie the number to the unit. You're the ones that are dropping the unit, okay? And part of that comes from what you've done in previous math classes. You associate numbers. When you go through and talk about multiplication, what do? Give me a multiplication problem. 5 times 6. 5 what? It doesn't matter?
In math, no.
In math, they go, well, it doesn't matter. As long as you know 5 times 6 is 30, you're okay. Okay? They're trying to help you deal with the numbers. There's a lot of meaning behind 5 times 6. Okay? And that meaning has very often disappeared from our consciousness because we decided it wasn't valuable. When does it hold that value? in the real world application like
Robbie and
chemistry.
Laura can both attest, because they were in Pam and I's learning community last semester, that it's not just the numbers, it's every specific problem's context. And she
Yes.
would definitely hammer not explaining the context.
And
of the
I'm not
numbers.
blaming all mathematicians at all for that.
Make sure we clarify
Right.
that one.
But if we think back to how we were initially trained, we were trained to deal with the numbers, and then we brought in meaning, right?
And that's true in history too. We're told that it's like we think we're supposed to memorize the dates, not necessarily what happened on those dates.
And that happens in a lot of cases.
First, like we get focused on the numbers.
I would argue in a lot of cases with chemistry, you're told to memorize an equation, but have no concept of the meaning behind why you're doing it. That becomes exceedingly problematic for most of you in this class, because how many of you are going to go on to do anything with chemistry? One person, two people. The rest of you are going to be like, well, why is this valuable to me? This is why it's valuable to you, providing that context. Okay? So you have to focus on that unit system, because that unit system is what's going to be applied outwards. Not the fact that you know what a mole is. Not the fact that you memorize 6.022 times 20 to the 20. Okay? We don't care about that. Okay? So don't put all of your emphasis behind those numbers. Put your emphasis behind the units.
So I'm confused
Right.
about when you use that.
So you tell me, based off of the information that's up there, when would be a good time to use atoms to moles of atoms? When you're being asked about atoms. Did the question ask about atoms? No. So should you use it? No. The unit tells you when to use it. The number does not. Okay? Focus on the unit. Okay. So, this question should look kind of familiar. It looks roughly like something from exam 2.
Is that what was on exam?
Okay? I don't think it's the exact one because I effed with it a little bit. Okay? But it's very similar to what was on exam 2. Okay? And a lot of people screwed it up. And the reason people screwed it up is you're like, well, I've never seen the unit of moles before. You don't have to know what a mole is to be able to use it. Okay? You just have to know what it's related to. You have to know that equality. Are all those equalities given there? Yes. Where did all those equalities come from?
Don't know, we just haven't.
1 mole of oxygen consumed is 2 moles of water are produced. That sounds like we're talking about the relationship between oxygen and water. Those are different substances. That might come from, yes, a conversion factor found where? In a chemical equation. You mean where we convert substances? Absolutely. That's the chemistry you have to know. A chemical equation allows you to convert substances. So that sentence at the beginning, you're supposed to get from a chemical equation. Do you know how to work with chemical equations, theoretically, at this point? So that's gone. 9 grams of oxygen. Does that sound like a conversion? No. So that's actually given information. 16 grams of oxygen equals 1 mole of oxygen. Does that look like a conversion?
Yeah.
Are you responsible for knowing how to convert the grams of a substance to a mole of a substance? Where's that information found? Are consumed. Then how many grams of water are produced? 18 grams of water equals 1 mole of water. What does that look like? A conversion. Are you responsible for knowing that one? So that question, everybody's like, oh, I can't possibly do this, now boils down to this. I gave you all of that information if you followed the process. We're now in the unit where you have to know where that information is found. This is why we talked about it early on. Follow the process so that when we get to this point, we're not having a conversation about the process. We're having a conversation about where to find those things, because that's the next layer on top of it. Currently, the conversation we're having is both, which is making the conversation a lot harder. Right? That's why I talked about it early on. I was fully aware that we're going to have to talk about it now anyway, because nobody believes me. That's fine. Right? I accept that. Right? That happens in a lot of cases. You don't believe someone until you see the repercussions of it. Okay? How many of you still write an essay the night before the essays due? Okay? Why? Because whenever I turned it in, I got a good enough grade, so I'm not going to bother to change. Okay? Is the draft work part of your grade here? Yeah, it was never part of my grade, so I didn't do it. Right? It's part of your grade because it improves the end product. Okay? That's why it's supposed to happen. We're giving you that help to make sure that you become a better student, that your end results are better in the next class. Ideally, they're better in this class. That's our primary goal. But really, our end goal is that it's better for the next class. Okay? And then if we push that further, we actually don't care about the next class. We care about
This class.
the rest of your life. That it's better for you in the next position outside of the classroom. That's where we want it to improve. Okay? And what I think personally sucks, for at least me personally, is how many of you are going to come back to tell me that it was better? Yeah. So I get to spend my life looking just at this class and being like, well, I didn't feel like you learned anything, so now my life sucks. Right? Yeah, it's brutal. Welcome to teaching. I would appreciate that. Kira, question?
I think you kind of already answered it, but basically you're saying the problem that was up there, what we had to do before, and now this is what we're going to get.
And this is what it's going to become. So let's walk through that, because what Kira just said was a really important statement. She said the question that we saw on exam 2, we will see again on exam 3, except we're going to remove all of that stuff that you're supposed to find. Yes. How close? Verbatim. So everybody that's frantically writing down, I know one of the test questions is doing a good job. The rest of you are like, I'll just figure it out when I get there. Okay, that's starting to shame some of you to picking up a pencil and writing down, I now know what one of the test questions is. Okay? If you choose to not remember that or practice that, that is your choice. Okay? I'm a little hurt by that. Okay? But that is your choice. Okay? Because we're not on the test, what could you possibly do with that information?
Figure out how to solve it.
And what would be your best resource to figure out how to solve that? Tutoring Center or me. Hey, I've got this question. I wonder why you have that question. Okay? I'm trying to give you that incentive to go back and figure that out. We good? Okay? I'm seeing a lot of people copy off the slides. Remember what Kira's question was about. Which exam? The second exam. So stop copying what's written on the slide and start thinking about where that question came from. Okay? So, in the 3 minutes we got left, let's take a break from conversions and we'll talk about some other kind of relationships. Water and solubility. Water is kind of a phenomenal molecule. We're taking the second most electronegative element, oxygen, and we're bonding it with the one of the least electronegative nonmetals. Okay? Which means the electrons in that bond are pulled to the oxygen. So if the oxygen collects those electrons, it becomes So I'm hearing lots of words. I heard positive, I heard reduced. It's easier than that. If oxygen gains electrons, it becomes negative. What happened to the hydrogen? The hydrogen became negative? So the electrons in that bond that were shared between hydrogen and oxygen all went to oxygen and the hydrogen got electrons too?
I'm sorry, no, it becomes positive.
There we go. Becomes positive. That would look like an ionic bond. It's not an ionic bond because they're both nonmetals. So I can't formally say that's positive and negative. So we come up with a new notation to describe that those aren't formally positive and negative, those are partially positive and negative. Those are our delta symbols. Okay? That is a lowercase capital delta in the Greek alphabet. Okay? If you don't like it, look it up. That's roughly what those are supposed to be, and that's my artistic rendering.
So the capital delta is the triangle, isn't it?
Capital delta is the triangle. So if we looked at something like salt, an ionic compound, what happens? Okay, well, why does the ionic compound dissolve in water? Well, the sodium ion breaks off as a positive, and what gets affiliated with it? What would be attracted to that positive atom? A negative, kind of like the negative oxygen. We end up generating an interaction that is now relatively strong enough that it can break the ionic bond. That's pretty cool. That's what's happening when we dissolve things. We're breaking those intermolecular structures in our ionic compound to make a new interaction. And ultimately, it's a lot of new interactions because another water molecule can bond on or interact on all sides of that sodium. The same thing's going to happen with the chloride, except what's going to be connected to the chloride? The hydrogen. Why? Chloride is negative, hydrogen is positive. That's why those charges align. Okay? So, I do actually want to get through one big thing before we get. If we take a look at our solutions, because that's now what we're talking about, we take a substance and we dissolve it in water. Take a look at the aluminum tribromide. What phase is it? Aqueous. If I'm now going to go through and do a conversion relating aluminum tribromide into silver bromide, okay, I could go through and use a chemical conversion system. How would I measure the aluminum tribromide? Would I use length to measure it? Okay, what would I use? Okay, I might use volume. Why would I use volume?
Because you can put it in a graduated cylinder. It's easier.
Why do I need to put it in a graduated cylinder? Yes. It's aqueous. It's with water, so it's a liquid. Okay? Is that volume just aluminum tribromide? No. It's aluminum tribromide
With water.
and water. Is water doing a reaction? Do you see H2O written in your chemical equation? No. So is water doing a reaction? No. So if we just converted that volume across, we're going to have a problem because that volume accounts for both the aluminum tribromide and the water. And the water isn't doing anything. Okay? Which means we have to create a new system to define how much aluminum tribromide is there in the solution. That new unit system is known as a concentration. In the case of chemistry, the unit system we use is molarity, capital M. This relates the moles of a substance to the liters of the solution. That should look really suspiciously familiar because that looks like a conversion factor, which means you get to do some conversions, okay, with another unit converting factor. Okay? With that, we've got to go ahead and end. You should be practicing these things like crazy. Our exam is in 2 weeks, and we're still fighting that process. You need that process.